Are you living in a smart home? If you are, you can go away and feel superior because I don't. This is part 2 of a series about trying to set up a monitoring system in my 47-year-old house for some variables like energy use and temperature. In this episode, we'll see how everything doesn't always go according to plan. But I promise it won't be like the cliffhangers in old movie serials. Ultimately, things do work out. Hi, I'm Gary. I make videos on technology subjects that interest me, mostly from the viewpoint of an actual user. In my previous video, I laid out a plan for monitoring some smart home sorts of things, mostly energy and temperature, in my very dumb house. This video is about setting up the measurements I'm interested in and getting them working. I said in the last video this would probably illustrate the right way to plan a project and the wrong way to implement it. The initial plan was simple and really had only 2 parts. Install some power and energy monitoring hardware for my heating and air conditioning systems, and put some temperature monitors in several important spots so that I could see how well the H&V system was working. I proposed to use these PSM004T energy monitors connected to an Arduino microcontroller, along with these Dallas Semiconductor DS18B20 digital temperature sensors, which supposedly give accuracy within 0.5 degree Celsius without requiring calibration. The intent was, hook them up, read them out, and there are your measurements. Spoiler alert, that did ultimately work out as intended, but I do want to point out a few things I encountered along the way that might be helpful to know if you think about doing this yourself. So consider this a lessons learned video, even though I could probably have guessed that most of them were going to happen. The first step was to hook up the energy monitors. After giving them a bench check, I started with the easy one, because my furnace electrical panel is in my basement only 10 to 15 feet away from my little electronics area where I expect the brains of this project to be located. I'm not going to get down into the weeds of electrical wiring here, but I do need to say that if you're not comfortable poking around in electrical panels, you should probably get someone else to do this sort of thing for you. I'm a PhD electrical engineer, which means I know enough to be dangerous. But I do have the advantage of having wired this house myself when it was built. Because most home electrical systems in the U.S. are 120-240 volt split phase, you would normally need to measure a current in both legs of such an electrical panel to get the total power of a load, because any 120 volt loads are connected only between one of the hot lines and neutral. Fortunately, my furnace, which is electric by the way, is a 240 volt load with no neutral line, and it's the only load in this panel. As a result, I can monitor the total current going to it using only one current transformer. So the installation of the first power monitor was actually easy. All I had to do was clamp the current transformer around one of the power leads and connect 2 wires from the 240 volts at the circuit breaker to the voltage inputs on the monitor module. Then I ran a Cat5 cable from the module across the hall and hooked it up to my Arduino. And lo and behold, it worked. The module tells me the current, voltage, power, and accumulated energy use, along with frequency and power factor, which I'm ignoring. Incidentally, in the first video, I proposed using the new Arduino Uno R4 Minima as my microcontroller, because it's more powerful than the older Arduinos. I may still do that, but in the interest of being a cheapskate, I decided to try using one of the older R3 Unos instead, since I bought this clone version from AliExpress for the princely sum of $3.07 or something like that. So far it's worked fine for the purpose. Whether it will ultimately do everything I want to do is yet to be seen. Next was installing the second power monitor for my air conditioning system, which is connected to a power panel in my garage. I rather expected this to be a problem for 2 reasons. It isn't easy getting wires out of the basement. There aren't any usable penetrations to the garage available after 47 years of adding stuff to the house. And it's more than a 50-foot cable run to the panel. It wasn't clear that the power module signals would be reliable at that distance without some kind of driver circuits. As it turned out, neither of those issues was a problem. I simply drilled another hole through the wall from the basement to the garage and ran the cable over the garage ceiling. The backside of the power panel is conveniently exposed because we never got around to finishing that wall, so there is some advantage to procrastination. However, the module did not work when I hooked it up. I spent a lot of time checking things like cable integrity because those 24-gauge wires in a Cat 5e cable are pretty easy to break if you pull on the cable too hard. Eventually, I was forced to hook up my oscilloscope at the Arduino end and verify that signals were being sent to the module but none were coming back from it. And that the same situation was also true at the other end, so it wasn't the cable. Here's the first possibly useful lesson from this exercise. Be very careful what you take for granted. I bought the two power monitor modules at different times. They're identical, but one of them came with a 4-wire pigtail and the other one didn't. So I bought a batch of the pigtails with the connector attached and wired one of them up like the first one. Both pigtails had the same 4 wire colors in them, so I assumed they were identical without checking. They weren't, not even close. As you can see, one of them goes yellow, white, red, and black from the ground end, and the other goes red, black, yellow, and white. Once I got that sorted out, the module worked fine, although I had to cheat and temporarily clamp the current transformer on a different circuit to verify it, because the air conditioning is not running in the middle of winter here in Idaho. That left only the temperature sensors to install and get working. I say only because they're much simpler in theory. They're a 1-wire data bus device with only 3 connections: power, ground, and the signal output. And also, in theory, you can connect as many of them in parallel as you like, because each one has a unique 64-bit digital address. I started with 10 of the waterproof encapsulated ones like this, and later I splurged and bought 5 of the open modules like this. They were 60 cents each, and I figured these might be easier to install indoors. But first I needed to test them all to see if they actually worked, because when you buy cheap Chinese parts, you're never sure if they're the real thing or not. So I taped the 10 waterproof ones together, wired them all in parallel, and ran an Arduino program, they're called sketches for some reason, to find their addresses so I could label them and keep them straight. Then another sketch let me read all their temperature values to see how well they match. As you can see, they don't give precisely identical outputs, and the total spread in their values at room temperature is in fact a bit more than the rated plus or minus ½ degree Celsius, or 9/10 of a degree Fahrenheit. But they're all close enough for my purposes. Since I had unused wires in the cable coming from the garage, I installed the first 2 there, one in the garage and the other outside on the north side of the house, connected through that same cable I use for the power monitor. A pull-up resistor is needed from the 5-volt line to the data bus, and it's recommended to install it near the sensor if possible. So here's the final hookup in the garage. This leads me to the next piece of advice for anyone doing this themselves. I use these terminal strips for connections because I hate soldering in the field, the wires are really small for crimp connectors, and I thought it would be easy to change them around if needed, and I could keep the connections organized this way. That last bit is true, but easy it is not, because they're not really made for 24-gauge wires. I probably spent half my total wiring time trying to get the wires connected reliably to these terminals, made worse by the fact that my eyesight is terrible a foot away. And in one spot I was standing on a ladder working overhead only 6 inches away from the terminal strip because of the joist spacing. Arg! So find something easier to make the connections. I don't know what. If you do, please say so in the comments. At any rate, the outside temperature sensors worked okay over that 50-plus foot cable, which eliminated that worry. That left the ones inside the house. I may ultimately install a bunch of them, because I have a bunch of them, but the most important areas for the moment are our living room and the TV room, along with the hallway where our thermostat is. Finding spots to drill holes and fish the cables through took a little exploration and some dust, but ultimately I got the cables in place through the jungle already there. The 5 new modules also needed to be checked out, so here's the breadboard setup I use for doing this and for comparing them to the encapsulated ones. It started out fairly organized, at least for a breadboard. After the bench testing, I chose 3 of the more promising ones, using several sets of comparative readings. Then I took them out of the breadboard one at a time, mounted them on a small prototype board with a terminal strip, to make them easier to hook up, or so I thought, and connected each one to its cable. They're just dangling in the air at the moment because I'm waiting on some enclosures I ordered to make them look like they belong in a house. I checked each one of them again with its cable using clip leads to the Arduino. So the whole setup got messier as time went on, and ultimately it became a tangled mishmash. Fortunately, by the time it reached this stage, all the sensors were installed and working. I took the 2 Arduino sketches that let me read the power monitors and the batch of temperature sensors, smashed them together, removed all the bits I wasn't using, and there you have it, a readout of both power monitors and all 5 temperature sensors installed in the appropriate places. I'm not including that sketch here because there's next to no original work in it, but I am including links to the examples I started with. The Arduino community is wonderful at providing examples for how to do stuff. Now, if I'd really been planning this project well, I should have laid the whole thing out in advance with at least a block diagram and preferably some kind of circuit diagram to work toward, instead of using a pile of sticky notes. But engineering rigor tends to get neglected in favor of getting results when you're doing it just for yourself. However, I have made a wiring schematic, so at least I have a record after the fact, because I really don't want to have to start over figuring it out when something quits working. That's pretty much the grand total of my accomplishments on this project to date. The next stage is to decide what I want to do with the data, besides stare at the values on a computer screen. I know I want to be able to graph it for analysis and comparison purposes, which will mean logging the data somehow. Should I use the data logger module I bought for the Arduino, or send it somewhere else, or set up a web server that I can access from another computer, or what? I don't know yet, and there are lots of possibilities. That brings me to my last lesson learned so far. You need to count the cost before you start something like this. It's taking much longer than I planned to get this done. If I was just doing this for YouTube, I'd be all stressed out by how slow it's going. But it's a great learning exercise, since I knew nothing about Arduino programming, or modern digital sensor technology, or even the CAD program I had to use for the wiring diagram. It's KiCad, by the way, if you're interested. I tried several free or open source CAD programs, and this one seemed the easiest one for me to get started with. So I hope you enjoyed this video, at least enough to keep an eye out for the next one. Or of course, you can subscribe to the channel, give the video a like, or hit that notification bell, and YouTube will hopefully bring it to your attention when I get it done. In the meantime, thank you very much for watching.